Thank you very much, Simon. I would like to add my welcome to everyone, as Simon has said, and I think we've got a very exciting webinar and details of a following webinar today to focus on ensuring accurate classification of BRCA1, BRCA2 and other HRR gene variants. So Simon and myself are representing two external quality assessment providers. I am the director of GenQA, which is the Genomics Quality Assessment Service, and Simon is the director of the European Molecular Quality Network, EMQN. We're absolutely delighted to have two experts in the field of BRCA and HRR variant classification joining us today, and they're going to share their expertise with you in this educational session. So we have Emma Howard from the West Genomic Laboratory based in the UK in Manchester and Liverpool, and Kathleen Claes from Ghent University Hospital in Belgium. So just to share the disclaimer and then moving on to the aims of today's session. So as I mentioned, we're going to provide two educational webinars to promote accurate classification of BRCA and other HRR gene variants. Today's webinar will focus on best practice guidelines. We're going to get an overview from our expert panel on the resources that are out there, the databases, and in particular reference to BRCA and HRR genes. We're also going to have some worked examples, one in great depth, and also some other simple and complex variants, so you can understand the process and the areas that we have to consider and the information to consider when classifying variants. As from today, we now have a live online genomics training and competency tool, which is now open, and participation, because it's online, is open to anyone who is interested to take part. It's about individual participation for your own continuing professional development, and it's not laboratory based. And the aim is for you to log in and classify 6 different gene variants and summarize the criteria used. Many of you will have participated in previous runs, so this is now classed as BRCA Run 5. The idea is then we will follow up with a second webinar on the 10th of December, and again our expert panel have very kindly agreed to go through their processes of classifying and the evidence taken into account to classify these 6 variants, and then we'll have a live question and answer session. So the objectives for these series of webinars is to provide an overview of the framework to classify variants according to the best practice guidelines that are available to us, to outline the mechanism of classification of somatic variants in particular, and why that is different from germline classifications, summarise the resources specific to BRCA and HRR gene variant classification, and as I mentioned, go through some worked examples of BRCA variants covering both simple classifications and those that can be more complex. So I'm now going to pass over to Emma Howard, who is going to give us an introduction around the different guidelines and the use of the guidelines for variant classification.
Thanks very much, Sandy. So like Sandy said, I'm just going to review the variants, just give you a brief overview, and thank you. I can see the slides now, and go into some of the variant classification. Okay. So there may be a little delay as we're sharing the slides, so just bear with me one moment.
Hi, Emma, you should now have control if you click in the middle of the screen.
Yeah, I've already done that, thank you, but it's not moving on. Okay, so as we're all probably aware, BRCA1 and 2 are large tumour suppressor genes with a range of variants throughout the genes, which include exon deletions and duplications too. And looking at the schematics, you can see that some of the key binding domains are also highlighted on there, and all those different variants that we see scattered throughout the entire gene. So it's really important that we know to screen the entire gene and not just some of the key functional domains. So the different variant types that are observed, and we're using BRCA1 and 2 as an example, taking them in turn, we see missense variants, where this is an introduction most often of a different amino acid in the reading frame. And you can see from the example here, ALA goes to valine. And we also observe frame shift variants, which can be caused by deletion or addition of nucleotides, which brings about a stop codon further down in the reading frame. Likewise, we see nonsense variants, and from the example here, you see a GAA in the nucleotide changing to TAA, which introduces a nonsense, a stop codon into the reading frame. And also I mentioned previously, we do also see large rearrangements in terms of deletions and duplications. And these can also be single exon deletions and dupes too, or much larger throughout the entire gene. So just touching on the IARC 5 classification system, which is the most common classification used to categorize these variants into classes. If we take each class in turn, so starting with class 1, which is defined as not pathogenic, and then class 2 is unlikely to be pathogenic. And for these categories, if your variant fell within these classifications, it would not be usual at all, and you wouldn't recommend using predictive testing on at-risk relatives. Following on from that, class 3 is defined as uncertain pathogenicity, and it does not confirm or exclude a diagnosis. So we're uncertain with the evidence that we've collated if this is a pathogenic variant or not. And for those variants, you know, quite often clinicians will carry on with a surveillance for the patient in this case. And then we've got the 2 higher classes, class 4, which is defined as likely pathogenic or consistent with a diagnosis, and class 5, which is predicted to be pathogenic, and this result confirms the diagnosis. And for these 2 top classifications, we would then offer testing for at-risk relatives, and full high-risk surveillance guidelines would come into play for those patients. But it's really essential to establish a causal role of the variant and whether it's deleterious. And this classification is a means to do that, and we're able to then recommend to the consultant. So looking at class 5 pathogenic variants, what do we mean by that? And can we call some of them without doing a variant interpretation? Can we make some assumptions? So taking it in turn in terms of the truncating variants, in most part, nonsense and frame shifts absolutely present as pathogenic in HRR genes. There are, though, some exceptions to the rule. And these are detailed in the box in the table here. So any BRCA1 nonsense or frame shift after the last 10 amino acids of BRCA1 needs to be a full UV in classification, because they can't, you know, they're not determined as pathogenic. And likewise for BRCA2, any nonsense or frame shift after the last 110 amino acids also need careful interrogation. And this is due to nonsense mediated decay in the last exon of the gene. Turning now to the splicing variants, most people assume, and the guidance out there, you know, you can take into account that +1, -1, +2, -2 in the concanical splice sites would mean that these were pathogenic. You shouldn't assume, however, that a splicing variant at +3, -3, or up to +6, -6 may affect splicing, because this is less predictable. There are, however, and it's worth highlighting, some exceptions to the +1, -1, +2, -2 rule, where you sometimes have in-frame RNA isoforms that can rescue the gene functionality. And the Enigma guidelines are particularly good at emphasising these, but we should always do a full literature search, because these are actually becoming more commonplace, and we shouldn't just take it as read. So we also see some missense variants that are absolutely pathogenic, and these are normally seen in very specific functional domains, highly conserved residues, and an example of which would be in the BRCA1 ring finger domain. But you know, all missense variants must have a full UV assessment undertaken on them. You just can't take those as read that they would be pathogenic. And lastly, large rearrangements, particularly deletions, are most in part pathogenic. There is just one exon 13 duplication, which is a common pathogenic founder that I wanted to highlight, which is common in the UK, which is pathogenic because it has been determined to be in tandem. There are other large duplications that are not described in the literature, and one needs to be really careful in proving that they are in tandem before assigning classification. So this is just really a catalogue of how unclassified variants and the different terminology that we can see when we read about them that come into play. And it's just to raise awareness that they all mean the same thing, that this is an unclassified variant. We actually don't know if it's pathogenic or not pathogenic. And this is basically a variant in a sequence, a genetic sequence whose association with disease risk is uncertain. And they can be termed a variant of uncertain significance, a variant of unknown significance, or acronyms such as UV or VUS are also seen. So it's just to raise awareness that these are also all termed unclassified variants. Now, turning to the guidelines, there has been various different guidelines over the past, sort of 7 or 8 years. And the first one that comes to mind, the MGF guidelines, which were released in 2013. These were followed by the American College of Medical Genetic guidelines. And I will say these are more based around rare disease. The American College guidelines were released in 2015 and are actually formed a very detailed guidance. And then following on from that, we've had the UK very specific guidelines of the ACGS with various releases and updates, which take the ACMG guidance and just perhaps make them more specific and detail more examples, and also include examples of how to report variants too. So they can be found on the ACGS website. Just to also emphasise that Enigma also do have their own set of classifications, a set of guidelines. This is a 5-class system as well, and it was initially devised and documented by the Enigma steering committee members and revised with input from the Enigma collaborators. The benefit of this guidance as well, and I think I mentioned it previously, particularly they have very good tables where they show variants that are in very highly functional specific domains, and these are around BRCA1 and BRCA2. And they also detail some of the splicing variants where they rescue the gene because of the mRNA functionality. And these can be found in the Enigma and should also be used when you're classifying your variant. So most of the schemes that GenQA and EMQN run, we classify according to the ACMG, and this is because they're more international guidelines and not specific to one country. So just turning our attention more focused on the ACMG, what do these cover? So basically they're classified variants into 28 different criteria, and it covers a variety of evidence, which include population data, functional data, segregation studies. De novo observations come in, but again, I mentioned that these are more applicable to rare disease. There's allelic data which is taken into account, and also in silico in computational predictions. But it's really important to emphasise you should be cautious of using the same piece of information twice. And when you look at the categories, how they break down, they define them into pathogenic evidence categories and benign evidence categories. Focusing on the pathogenic categories, there are 4 of which, broken down into very strong, moderate, and supporting. You can see that for very strong, this is PVS1, so just one category it breaks down to. And then the strong category, it breaks down into 4 strong categories. Moderate is 6, and supporting breaks down into 5. The benign category, there's 3 of them: standalone, strong, and supporting. BA1 is the only standalone category. There are 4 strong categories and 6 supporting categories. And how does that look if we were looking at the interpretation? So just looking at a couple of examples, I mentioned population data, and a pathogenic criteria that you could apply is PM2, which is a moderate criteria. And this is when you see a variant which is not on any population database or very, very low frequency. And also looking at the functional data tab there on your left-hand side, we can apply a strong piece of benign evidence if there is 2 reproducible, robust functional assays that define the variant as being non-pathogenic. And it just gives you an example of how this accumulated evidence is put together. So how do we then classify? Once we've gone through all these data sets and applied the criteria that's applicable to your variant, how do we then classify it? Well, there's a table how it breaks down, and basically you accumulate the criteria is then compared to this classification table. For example, pathogenic, for instance, you would have to have at least a very strong, and so one very strong and one strong, or one very strong and two moderates, or one strong and one moderate and one supporting, to then meet that criteria of a full pathogenic variant. One thing to highlight is if your variant doesn't meet any conclusions, then that remains at uncertain significance, which would be class 3. There are some issues around this. Like I said before, they're based around rare diseases. De novo status is not applicable for HRR genes. It takes into account phenotype quite often in these guidance, and locker-specific databases, which for BRCA1 and 2 are particularly, we do quick, you know, that they've highly curated. We've got BRCA Exchange now, we've got Enigma Consortium that feeds into that, and they're not actually given a very high weighting. And it's really advised against on the ACMG of using PP5. But for BRCA, it feels like a locker-specific database weighting, where they've been highly curated by an expert committee, should come into play to define that criteria. One thing to add though, these are guidance, and when I teach my team how to go about, we must take into account that you need to use your professional clinical judgment, because sometimes the guidance does not go far enough. And, you know, as scientists, that we should make, you know, not rely on them solely, and that our judgment must come into play. So I wanted to highlight here these new guidance, which are more applicable to cancer susceptibility genes. And these are CANVIG guidance. These have only been released for general use in October at the website highlighted in the slide here. What they do is they actually take the ACMG and ACGS guidance, and then they break it down to provide more clarity specific to cancer susceptibility genes. And the categories are still the same. However, if I give you an example here of a functional assay, sometimes with functional assays, it's hard to glean out when you read the literature if this is a really credible assay or not. And what they define, if you're able to use a strong piece of evidence in a functional assay, if you collectively are using greater than 3 positives and greater than 3 true negative controls, and that you also, the literature and the assay demonstrates that the relative protein activity drops below 25%. So it's really a detailed criteria in order to apply a piece of evidence. And I would recommend that anybody who's looking at HRR genes and variant interpretation takes a look at these very specific criteria. So just moving on and keeping with the CANVIG guidelines. You know, like I said before, some of the guidance in this is very CANVIG specific, where they've drilled down far more detail into variant classes. So for instance, this is a PS4, and this would be applied when the prevalence of the variant in affected individuals is significantly increased compared to the prevalence in control. If you look at the highlighted boxes in red, it actually defines it in a very detailed way, that it says non-duplicated, robustly genotyped case data and control data from equivalent ethnic groups are required. So, you know, I would recommend reading these in detail. And just another guidance is, like I said before, it's very, you know, they have produced very specific guidelines, and Appendix 1 of these guidelines defines the differences, because they're shaded in grey, between that and the ACMG guidance. And if we look here at PM1, which is a piece of evidence that you can apply if your variant is located in a mutational hotspot and or a critical and well-established functional domain, you can apply this piece of evidence at a moderate setting for a variant in a mutational hotspot where there's no benign variation. But you can apply it in a supporting setting if it's in a mutational hotspot where there's some benign variation. And these are very, very small nuances, but they give you that ability to accurately classify your variant. So my final slide before I hand over to Kathleen is just to point out that there's a set of guidelines, the AMP guidance, which are more somatic focused, and these are evidence-based categorization of somatic variants are classified into 4 tiers, basically on the level of clinical significance in cancer diagnosis, prognosis and therapeutics, where tier 1 here is of the strongest clinical significance, and tier 4 here being for benign or likely benign variants. And quite often, if we you know, if we see variants coming through a somatic pipeline where we're looking at therapeutic options, we will use these in conjunction with the germline guidance of the ACMG and CANVIC to formulate an overall response or a classification for our variant. So that's a very brief overview, because obviously we're time limited, but I'm going to hand you over to Kathleen now, who will take you through some of the worked examples.
Before we go to Kathleen, sorry Emma, I'm going to interrupt there, because I first of all like to say thank you very much indeed for that really nice introduction to variant classification. I think, you know, we can all see it's a very complex subject, and Emma, I think, has presented a very nice introduction to that. If you have any questions about the specifics about the what Emma's gone through, then please, as I said before, do feedback to us via the chat function or email us afterwards. Before we get on to Kathleen with some of the worked examples, I've got a couple of questions for both Kathleen and Emma, starting off with Emma, really around sort of resources available to laboratories and individuals for actually helping manage the classification. Emma, can you give me an overview of the types of resource that you might use for variant classification?
Yeah, so you can use things like variant databases, for instance, such as there's more population frequency databases such as NOMAD and EXAC that you look at, and variant classifications for those. And then there's also you know, your locus specific. So the population frequency database gives you an allele frequency of your variant if it's on there. And then there's locus specific databases, which also provide classifications. You know, some like BRCA share, for instance, you can look at BRCA exchange, there's the Myriad database. Also we look into literature searches, co-segregation data, bioinformatic analysis where you're looking at in silico tools as well. The literature searches are really useful for establishing if there's any segregation studies out there or if there's any functional studies out there. And then the in silico studies that I mentioned, you look at conservation and physiochemical properties, and they also look at the splicing and take into account like 4 or 5 different tools that assess if there's a deleterious effect due to a variance effect on splicing as well. So these are some of the resources that we can interrogate in order to perform an accurate UV assessment. So
would you be able to provide so if the workshop participants emailed in, or would you be able to provide a sort of list of those resources at all we can make available?
Yeah, that's absolutely fine. We've got a list of some of the population databases and certainly the locus specific databases that we could share with the group. Absolutely, that's not a problem.
Fantastic, thanks for that. So Kathleen, I've got a question for you. So where do I look for evidence of my co-occurrence of my variant with a known pathogenic variant in the same gene? So in this case, we're talking about in trans specifically.
Well, there is a good source that the French labs collected, a database that's made by the French. It used to call UMD, but now it's called BRCA. And I will come back to that later in the work examples. There we have also used it to classify the variants.
Fantastic. And I guess it's the same thing as we could probably make that available to the participants, a link to it if they're not familiar with that.
Yeah, that's fine. Absolutely.
Perfect. Fantastic. Emma, I think I've got one more question for you. So if an in silico prediction programs for a missense variant conflict, how do I interpret this?
Oh yes, so that's a really good question. So if you conflict, you need to be really cautious, but I think the guidance says that it needs to have at least 3 out of 4 that are consistent and agree, and that one of them should include polyphen. So yeah, you just need care needs to be taken, and you shouldn't use in silico alone to classify variant. We shouldn't overinterpret this piece of evidence.
Yeah, and I think that's a very good point, isn't it? It's about not overinterpreting the variants, making sure you're confident with what you're trying to predict. Lastly, Kathleen, so I've got one last question. So there are various resources like ClinVar and HGMD for giving me variant classifications. Should I use these?
You mean ClinVar and HGMD? Well, there are some differences in the quality of the data that are available for the different submitters. So I find it a hard question to answer, but what I find very helpful and what I tell to the people of my team is you can read the information that's written by some of the companies, really write very detailed arguments, and you can really use it to put it in your classification system and to come to see how heavy this evidence weights in the system you're working with. So you can use it. It's definitely, it's also the first thing I look at as a basis, but then you have to go to move much further, especially if there are inconsistencies in classification, or if there is not yet, if it has not yet been classified by an expert committee like Enigma.
Fantastic, thank you, Kathleen. So, well, what we're going to do now, what the rest of the presentation is going to do is really focus on specific worked examples, and we've got a couple of simple examples, and particularly in the first case, a very complex, the full workflow and how we've classified this particular variant, and then we've got a couple of more complex examples to give to you. So the two speakers are going to divide the workload up between the two of them. So I think we're going to start off with Kathleen with the sort of detailed breakdown of simple variant classifications. Over to you, Kathleen.
Yeah, thank you, Simon. So I will just jump in very concretely to a specific variant. In this case, it's a BRCA1 variant at position 5071, an A2G, which induces amino acid substitutions at codon 1691. The threonine is replaced by an alanine. As you see, it's a missense variant, non-synonymous, and the prior risk of pathogenicity is not clear. However, we know it's located in a functional domain, the highly conserved BRCT domain. Like I said before, the first thing we can do is going to locus-specific databases, and BRCA Exchange is a very nice example where you can look if Enigma has already classified the variant. In this case, the variant has not yet been reviewed by Enigma, so yeah, there is no strong argument pro or against pathogenicity. AGMD, there is also a database where it has been mentioned, and in this case, I cannot see the lower part of my screen. In this case, the variant has not been classified. BRCA Share is another locus-specific database, and which is very useful to look up if there are co-occurrences with other pathogenic variants. In this case, there is no co-occurrence with the pathogenic BRCA1 variant, but we see one times a co-occurrence with the BRCA2 class 5 variant. Of course, this does not weight too much, because it's in another gene. It would be a different situation if it would have been in trans with the pathogenic BRCA1 variant, because in that case it would be a strong argument in favor of a neutral effect. LOVD is another locus-specific database which is very useful, and many people are submitting their data, especially the Dutch labs and the Belgian labs. All the data are collected in this database, and you see that different labs have identified this variant in their patient population. You see it's also here classified as a variant of unknown clinical significance. In ClinVar, it got 2 stars because it has been submitted by different labs, but there is consensus about the classification, uncertain significance, but it has not yet been classified by an expert committee like Enigma, otherwise it would have received 3 stars. Bioinformatics then, well, there is a line GVGD that you can use, and here you see that the variant gets a quite high score. It's C55, which tends to be towards a pathogenic effect. So generally, it's advised to be with this program to be careful starting from C35. Predictions in SIFT are that it affects protein function. Then in mutation taster, it says that it's also disease causing. Polyphen is, Polyphen 2 is one that we like, that we like a lot. But here you see it's possibly damaging or and benign. So it's also not very helpful. But as stressed by Emma before, the bioinformatics tools should not weigh too much in your classification system. Regarding splicing, so you see it's the variant is located somewhere at the end of the exon. It's the fourth last nucleotide of the exon. However, there is not much to see about on the predictions. It's not expected that it will induce a large change because it's only splice site finder like. That tends to create a novel donor site, but absolutely not confirmed by the other programs available through Alamut. Conservation, this is also a sprint screen from Alamut, and as you see, it's a highly conserved nucleotide amino acid in the BRCT domain. So summarized, we have a lot of information, which is often the case for variants in BRCA1 and 2, because they must be a bit the most worldwide, the most sequenced genes. We have some evidence favoring a pathogenic effect. So PP3, multiple lines of computational evidence supporting a deleterious effect. We have PM2, it's not present in population databases like GNOMAD. And PS4 moderate, it is identified in multiple unrelated affected individuals. As we have seen in ClinVar, it has been reported several times. We have no evidence that it would be a benign variance. There are some functional data available in the literature. However, the effects are not clear. So there is the genome editing assay that has been published 2 years ago in Nature, and this shows an intermediate effect. And then more recently, Peter Bouwman and his group published a large cohort of variants functionally assessed, and they found it in the cisplatin assay as neutral, while in the olaparib assay it was intermediate, and in the HR assay it was deleterious. So in this case, we do not add a point for the pathogenic effect due to in functional assays. So altogether, we have PP3, PM2, PS4, and moderate. So it's predicted as a class 3. Of course, there's not always so much work to do about variants. It was listed as a simple variant, but it already takes some time to assess such variants in detail. More easy are variants that cause a frame shift and a premature stop codon, like this one in BRCA2. It's a deletion of one nucleotide at position 1013, which leads to a frame shift starting at alanine 338 and leads to premature stop codon 11 amino acids downstream. Because it's a frame shift inducing a premature stop codon, the prior risk of pathogenicity is of course high. And is it in a functional domain? Not really described, but maybe not so relevant in this case. So here we can go much quicker. We checked it in the different databases, BRCA Share, GNOMAD, BRCA Exchange, ACMG, ClinVar, and we did not find it. However, we can apply PS very strong because it's a null variant in a gene where loss of function is clearly the known mechanism of disease, and it's not present in population databases. Therefore, this is also a moderate parameter for pathogenicity. Based on the publication of Taftijian et al. In 2018, one very strong and one moderate can be considered as a class 5 variant. So we classify it as a class 5 variant. Then I would like to hand over the word to Emma to discuss some more examples.
Okay, thank you, Kathleen. So the last few slides, we've just chosen 2 worked examples. So these are, the first one being in BRCA2, and we've chosen this because I think from my introduction, you'll have remembered that I talked about those splicing variants that sit outside those concanical splice sites that need to have a full UV interpretation done on them. So this is BRCA2 C.632-3 C to G. And the prior probability of pathogenicity from Parsons' paper in 2019 is high. Sorry, there's just a bit of a lag with the slides, bear with me. Okay, so how the panel applied the variant classification. So basically, first of all, we looked at the databases. It was on Nomad, but a very low frequency at 0.00041%. It's also seen on BRCA Exchange, ClinVar, HDMD, LOVD, and BRCA Share. So the crux of this, although the in silico evidence was favouring pathogenicity, was in order to apply a strong piece of evidence in the functional assays, was to look at those assays and define if they were credible assays. One thing with the functional work is that they need to be reproducible and robust. So when you're looking into them, it's important to read the detail. And so the Hudea in 2012 is a very credible paper, and it did show that this variant caused aberrant splicing. And also this was backed up by a second functional assay in the Frail Bethencourt paper in 2019. We also applied the PS4 moderate piece of evidence because this variant was observed in multiple unrelated affected individuals. And this can be information that we got from ClinVar and LOVD, but also it was information that you may have locally too in your local databases in order to apply that. And this gave us an overall prediction of class 4, PS3 and PS4 moderate. If we hadn't looked at the functional studies in detail, we may not be able to apply that PS3 piece of evidence, and then it would have been a class 3, and that would not have been an accurate interpretation of this variant. So it's really important to emphasize that you read these papers in detail. So the second one that we chose was a BRCA1 variant at C.203T2A, P.isoleucine 68 lysine. This is a missense, non-synonymous variant with a prior risk of pathogenicity as uncertain as defined by Parsons et al. 2019. So the data resources that we interrogated, it was on BRCA Exchange, but it was not reviewed. It was on ClinVar, LOVD, and HDMD. It was not on Nomad, and it was on BRCA Share. So the evidence that we applied for this, and again, going back to my previous comment about the functional assays, we were able to apply this in the strong setting. Now, in order to do that in strong, as in the previous variant, we looked at the functional studies that were available, and the Findlay et al. 2018 functional assay. There was some debate from the experts if that they used a saturation genome editing assay, if it was actually indeed a credible assay. So what we did then, we looked at the Bernish et al. Paper, and that forms an evaluation of some of these functional studies, and they looked at Findlay in more detail and did actually identify that this was a very credible assay. So we were able to apply that. And also the second functional assay was described in this Sarita et al. Paper. So very detailed in looking at these functional assays in very detail and bringing in other publications to verify if their assays were credible were also a piece of work that the experts did. And we felt that we could then apply that strong piece of evidence in PS3. So we also applied PM2 because, as I said before, if it's not on any population database, if it's absent, then we can apply PM2, a moderate piece of evidence. We applied PS4 moderate because the variant was identified in multiple unrelated individuals. Again, ClinVar and LOVD, there was multiple submissions that were affected people with breast cancer. And we applied PP3 as an in silico piece of evidence. Computational evidence provided support that this was a deleterious effect in the supporting setting. So overall, this gave us PS3, PM2, PS4 moderate, and PP3, which gave a classification of class 4.
Great. Thank you very much, Emma, indeed, and Kathleen, for that very in-depth interpretation of the variants. I think we've got lots of questions coming through as well. So let's kick off with one. We're going to kick off with a very difficult one, I would say, and we probably may not be able to answer that right now, but can give some written feedback. So I'm just moving. So the question is let's move to Emma first of all. What is your opinion about the multifactorial model for BRCA1, BRCA2 variant classification, as it has been widely used by Goldar, Lindor, and other clinical cancer labs? Now, I think that's quite a difficult one to ask.
And I think it goes back to me saying you need to interrogate the detail of them. So there's some excellent ones. The Parsons paper, which is a multifactorial paper, is held in very high esteem and can form, the detail that's in those papers then become evidence parts for applying in the guidance as well. So we wouldn't use them as just a standalone piece of evidence to say these trump everything, because it's but they can be used in addition to other criteria. So again, it's just building that picture up in the guidance and using those good, credible multifactorial models and publications where they're detailed in to formulate your answer. And we can give a more detailed view offline, but yeah, it's just knowing the ones that are good and the ones that aren't so good.
Yeah, that's really helpful, Emma. And I think it builds on the theme of today. The take-home message is that it's not just a one place to go for that answer. You have to build the evidence and use the expertise and knowledge of where the criteria is more important to put more confidence in there. Thank you. Kathleen, can I ask you one question about one of the variants that you were talking about? So this is BRCA1, the C.50718G, and you applied the PS4 supplementary criteria. So the question is, I would say that breast cancer is not a specific enough phenotype to use this criteria. Do you want to comment on that, please?
Yeah. I find it a difficult question to respond to because indeed breast cancer is not very specific, and we know that 1 in 10 women develops breast cancer, and there are the problem with phenocopies. However, the variant is not present in GNOMAT. It's present in ClinVar in the context of breast cancer. So yeah, I have a tendency to use it. If it should be moderate or just supportive, well, it's rather supportive. It's something, yeah, we can discuss. For this concrete variant, it would not make a big difference. We would end into class 3. But yeah, as Emma stressed before, the classification rules have been made for rare disorders with clear phenotypes, and unfortunately, breast cancer is not one of these. So it makes it more complicated, and we need therefore stronger available evidence. Nice segregation data can also be helpful if there are pedigrees published. It's more informative. But yeah, we sometimes just have to work with the things that are there. Yeah.
Not always black and white.
That's true. Yeah. Also, we have this not fully penetrant phenotype. So in that case, it's a hard gene to work with. Yeah.
Yeah. Great. Thank you, Kathleen. Simon, do you have a couple of questions?
Yes, it is.
You're still on mute, Simon.
So thank you, Kathleen, for that. I've got a question for you, Emma, actually. So this is a question from Paolo. What is the best source of finding information about the exact position of protein domains?
Yeah, so that's a really good one, because they're not all. So sometimes literature searches are a really good way of doing that. I normally start with those, actually. Kathleen, do you have a go-to position for this?
For which?
For binding domains, where you find
binding domains. No, I made some. Yeah, I take them often from the literature. For instance,
I do
the
too.
paper from.
Isn't they? But it would be nice for them to be on a website all in one place.
Yeah. But for instance, in the Messman paper, there is a very nice overview of the BRCA2 functional domains. And for BRCA1, there's a paper, I think, for 2012. I still use these as kind of reference. And when I train my students and my colleagues.
Yeah, and I think HGMD provides a nice overview as well, because you're able to see the literature associated, and you can sort of see if the functional domains fall into specific exons on HGMD, but it's not, it's not your first go-to point, but I'd start with the literature.
Yeah, and not everybody has access to HGMD because you have to pay.
No, that's true.
So
very true.
Yeah, that's a very good point.
Yeah.
So building on that, I suppose, another question, but this time for you, Kathleen, from Paolo, is, do you use REVEL for computational predictions?
Yes, we started using it in the lab because it's easy to work. Well, REVEL is a combination of 13 different tools. So it gives you a value, and it's easier to interpret then, because we use then a kind of cutoff. If it's above 0.7, we consider it as an argument pro-pathogenic effect, and it's easy to explain and to build into the bioinformatics pipeline. We have validated it on a large number of exomes, of course not specific for familial cancer syndromes or here BRCA1 and 2 in particular, but yeah, for us in this large cohort, it worked quite well. It was the best way to use it with all the limitations we have been talking about. Yeah.
Thank you, Kathleen. I'll hand over to you, Sandy, for the next couple of questions.
Great, thank you. Yes, they're coming in fast and furious, which is fantastic. So Emma, one for you. Which resource would you recommend for PP2 evidence?
PP2. Remind me what PP2 is. So this is exact constraints. Yeah, so we go into, so this is where we look at missense variant in a gene that is a low rate of benign missense. So basically we'd look at exact for that, but actually the best way to do it is go directly into exact rather than going through Alamut if you've got an interpretation tool, because it enables you to see the exact constraint scores. The thing is, BRCA, for instance, it doesn't really have a low rate of benign missense mutation. So, again, it's probably more applicable around the rare disease side of it.
Yeah, great. Thank you, Emma. The next question, probably to both of you. Kathleen, maybe first, what's a better way for classifying the variant, automatically or computationally, for bioinformatics methods? I guess this is because there's a lot of commercial products around now that can do that interpretation for you. What's your views, Kathleen, on the way to do it?
Yeah, I do not fully understand what's the difference between bioinformatically and computationally. It's
so I think it's more about doing it yourself, interpreting the data, or running it through a program.
Well, if I was not sure if it's about checking the bioinformatic tools, so that we have been discussing. There, it's easy if it's somewhere in your bioinformatics pipeline, and you can just see it in the list. That's the way how we work, at least in our lab. All the variants are automatically going through a pipeline we have built in-house with the different tools we have been discussing here, but it does not automatically compute the class. There are some tools available online, like the ARUP laboratories have some tools, and there are some Intervar is also like a tool like that. But what I see, or Varzome is also something that's used by some people, but what you see is that these things make mistakes. You have to be very critical and not automatically assume the parameters, agree with the parameters they are using. So I'm very careful with automatically calculated things. It can help you, it can support you and give you a first ID, but you have, I remain critical towards it.
Thank you, Kathleen. Simon, I'll come over to you because I think there's another question it's quite similar, I think, or following on from that one.
Yeah, so it's what do you think about commercial softwares that perform automated classification and integrate updated information in one place? Manual review of all data sources can be tricky because many sources are not open and some of them might be missed as well. So do you, both of you, have any sort of thoughts about that at all, about utilising software to automatically classify variants?
So if I'm honest, I think we're moving more in that direction because of the number and the volume that comes through. But I don't think any software can take into account every nuance that a person would be able to interrogate. So it's what you feel is acceptable. You know, I said before, the guidelines aren't perfect and clinical judgment needs to come in, and I would still absolutely stand by that. But I do appreciate that the volume sometimes and the time that it takes for people to interpret, people are turning more toward these interpretation platforms, as I call them. I think they need thoroughly validating. So that's what I would recommend, that you take on a validation series, that you've got your classification that you've done manually, and you put perhaps a number of them through, quite a number, to see if the classification on the interpretation platform comes out with the same. And that's a way of just validating that platform in order to accept it into practice. And it would have to be documented. That's how we do something like that.
Yeah, and the outcome may also be dependent on the gene that has been tested. For some genes, I think it might work very fine, and for others, it might be more difficult.
Right. Yeah, and of course, we are talking about quite a complex setting with BRCA and the HRR genes. So, you know, I think you've demonstrated in your examples how complex these can be. We've only given 4 variants, and you can see there's a huge amount of data gone into classifying each of those 4 variants. So I think I would agree with you that, you know, it really needs to be more of a holistic approach and taking into account that there's multiple different data sources.
Sorry, just to add very, very quickly, how adaptable and flexible are they when there's an update to guidance as well?
Yeah.
Is that?
Absolutely, I totally agree with you. Okay, I guess moving on to that, then there's another question really more related to the guidelines themselves, and in particular the ACMG. So for the PM2 rule, in September 2020, the ClinGen Sequence Variant Interpretation Working Group proposes decreasing the weight of the criterion PM2 to a supporting level, strength level. What do you think about this proposal?
It's hard. Well, it would just be an opinion. I think if they've done a lot of work to support that decision, then, you know, we have to stand by it. It's obviously not been done on a whim. You've got to take into account that some variants are extremely rare and just wouldn't be seen on the databases. And then you're applying a moderate piece of evidence, which is quite high weighting in that case. And some variants are only seen in certain ethnic groups, which may not be reflected so well in some population databases. So actually, you know, I'd probably agree and support that, but they're the ones that have done this piece of work and have the evidence to suggest why.
Thank you, Emma, for that. So we've got 2 more minutes before the end of the webinar, the official end of the webinar. So we've probably got time for one more question, I think, before we wrap up. So I'll hand over to Sandi for the last question.
Yeah, I'm just going to pick one here. There's quite a few queries about which criteria to apply in certain circumstances. And I think a lot of these questions are very pertinent. So we'll try and collect them and address them in the next webinar in December. But just to finalise this one, can we use PS3 and PP3 together? Or isn't that double counting? So we need to use evidence only once. So what's your suggestion there? Kathleen, will we come to you? Do you have an opinion?
Yeah, I just have to look up. I still don't know these criteria.
Do you want me to take it, Kathleen? I think.
Do you want to take it, Emma? So yeah. It's PS3 and PP3.
So where you've got in silico evidence, but you've also got, so for splicing, for instance, if you take a splicing variant, if you've got functional data that shows mRNA splicing, then you don't use PP3 in that setting. You use your functional piece of evidence. So you don't use that, but you can use it with missense variants together with functional, but not with splicing. Is that your interpretation? I'm sure I'm right there.
Kathleen, anything to add, or are you in agreement with Emma?
Well, yeah. So PS3 for splice mutation can be, well, in my experience, quite valuable, and PM3 is more about co-segregation. So I think that's quite a useful criteria. If you have a variant in trans for BRCA1 and BRCA2, it's for me a very strong argument, well, a good argument against pathogenicity. So if I correctly understood the question.
Great, thank you very much. That sounds that we can conclude the webinar today. I think it's been incredibly educational, successful. I've definitely enjoyed it. Can we just pop that screen back, Amy, by any chance? Thank you. Just to clarify that this login registration, the BRCA and HRR should be in capital letters at the end of that website. So some people have been trying to log in and it doesn't take you to the correct link. So we will make sure that that is circulated to you as well. So finally, just a very big thank you to Simon, my co-chair, and Emma and Kathleen for all their participation today, and of course to you for logging in and joining us. And I do hope that you participate in run 5, and we can then come back on in December to review the data and the variant classifications together. So a very big thank you to everyone.